Here in this video, we are going to solve 3 problems that appeared on system of particles in NEET 2022. Let us have a look at the first question. It says, the angular speed of a flywheel moving with a uniform angular acceleration changes from 1200 rpm to 3120 rpm in 16 seconds. What is that acceleration is, right? Let us try to solve this question, first question. It is given that it is having a uniform angular acceleration, that means alpha equal to constant, and you have to find out how much is that, which changes the angular velocity from omega. First of all, we shall know what is the formula is. Angular velocity is rate of change of angular displacement d theta by dt. For one revolution, it covers an angle of 2 pi. Time taken for one revolution is called time period, 2 pi by t, but 1 by time period is frequency. So, other way of saying angular velocity is omega equal to 2 pi n or n1, where n is, be careful, number of revolutions per second, but he has given n1 as 1200 rpm, revolutions per minute. So, I shall convert that into seconds. Revolutions per second means per minute there are 60 seconds, then that becomes revolutions per second or frequency. So, that becomes how much? 1200 by actually 60, so 10 will cancel, 120 by 6. So, how much it will be? 20, 6 twos, no? That is frequency 1. Frequency 2 is 3120 by 60 rps, 0 will cancel, then 6 5s are 30 and 6 2s are 12, 52 rps. Now, you want angular acceleration is how much? You know the formula, something like v equal to u plus at in translatory motion. In rotatory motion, instead of linear velocity, I have to just write angular velocity. So, omega final instead of v, omega initial instead of u, instead of acceleration, angular acceleration, alpha and t. So, alpha will become omega final minus omega initial by time. Omega final is, as per our formula, 2 pi n final minus n initial, 2 pi is common, by time taken. So, this value is 2 pi. We found n final as 52, n initial as 20. In a time of, he has given it for you 16 seconds. So, this is 2 pi, 50 minus 20 is 30, 52 na, so 32 by 16, 16 2s are 32. So, 2 pi into 2 is 4 pi. So, the unit is 4 pi radians per second square. That is how we get the answer for the first question. So, we solved the first question in the list, right. Let us go to the second question. This question, what does this question says? The ratio of radius of gyration of a thin uniform disc about an axis passing through center normal to its plane to the radius of gyration of a disc about its diameter is. So, there is 2 questions in this. So, first of all, I need to know it is a disc, filled one, inside it is not empty, it is not a ring, it is filled. Now, for a disc of mass m having a radius r, moment of inertia about an axis passing through center perpendicular to the plane. I am writing a dotted line, it is not across the diameter, but perpendicular to the screen that I am saying, that is why I have a dotted line. Moment of inertia of that I is mr square by 2. I have derived this derivation, now I am not going to derive, just need to know that formula. For a disc about an axis passing through center perpendicular to the plane, moment of inertia is mr square by 2. That can be expressed as radius of gyration mk square. Being a first case, I am calling it like mk1 square. m can be cancelled. That implies k1 square equal to r square by 2. That implies k1 equal to r by root 2. That's the moment of inertia of the first case. Now there is a second case. What is that second case is, in case 2, same disk but moment of inertia about its diameter. This is the diameter. So be careful here. Here the axis is passing through the diameter, not perpendicular to the plane but in the plane. I need to know what is the moment of inertia of this disk about its diameter. For that we shall remember back a theorem called perpendicular axis theorem, which says that Ix, I am not explaining all perpendicular axis theorem now. I have made a beautiful detailed derivation for that. You can just go through that, right? Iz. It says that moment of inertia of a body about an axis is sum of moment of inertia of the same body about two perpendicular axes passing to the same point. So what is this? Iz is in plane and Ix, Iy shall be perpendicular to the plane. They are not in the plane but perpendicular, they are perpendicular and perpendicular to the plane also. You know, this is perpendicular to the plane, this is what like we said. So what we can say, Ix is perpendicular to the plane, Iy is also perpendicular to the plane, Iz is along the diameter. So what we can say, these two are equal. How much are they? Perpendicular to the plane we have already told you, mr square by 2 and right. Alright, let us rephrase this way. I will call this I diameter as Ix in the plane. I will take another I diameter, this is also the diameter. I will call this as Iy, that is also in the plane. Now I will take another axis, this axis, yeah. I will take a different color, yeah. This is Iz. So Iz is perpendicular plane, Ix and Iy are in the plane. This is our perpendicular plane, that is mr square by 2. So I will write I in the place of this Ix, I will write I diameter, this one. The place of Iy also I will write I diameter. Then I will write Iz as this because that is perpendicular to the plane, that is mr square by 2. So 2 times of I diameter is mr square by 2. So I diameter is mr square by 4. That is the moment of inertia about the diameter. That mr square by 4 can be written like mk2 square, where k2 is the radius of gyration in the second case. M can be cancelled. So k2 equal to r by 2. Now you want the ratio of k1 by k2. You got k1 already, r by root 2, k2 has r by 2, so it will be reversed 2 by r. So your answer is root 2 is to 1. That's the answer for the problem. That's the second question. Once completing the second question, I can go for the third question that is there. What is that third question is? This is the third question. Two objects of masses 10 and 20 are connected to the two ends of a rigid rod of length 10 meter, negligible mass. The distance of the center of mass from 10 kilograms is. It's a very simple question from center of mass concept. This is m1, this is m2, they are separated by a distance d. You want the moment of inertia from m1, so that can be taken like as a reference 0 0. This distance becomes d0. Then I have a formula xcm equal to m1 x1 square m2 x2 square by m1 plus m2. But being this as a reference, x1 equal to 0. So xcm is, this becomes 0, m2 that is 20 and then this other one value, it is like m1 r1. So sorry, I have missed something by saying there is no square actually. Oh, come on, I'll just correct it. Yeah, XCM, have a formula of XCM is m1 x1 plus m2 x2 by m1 plus m2. Being m1 is the reference origin, x1 becomes 0. So m1 is 10, x1 is 0, m2 is 20, x2 is this term automatically, that distance is 10 by m1 plus m2 means 10 plus 20, 30. So this is 200 by 30, that is 20 by 3 meters. That's how we solve the problem. Anyway, there is another way to solve this problem. I will just solve this problem in another way. This third problem, I will solve in another way too. There is m1, there is m2, center of mass is somewhere at a distance x, this distance becomes d minus x. The point is that the definition of the center of mass is algebraic sum of moments about center of mass is 0. That means what? m1 of x equal to m2 of d minus x, that is the moment, mass into distance. m1 is given as 10, x I have to find out, m2 is given as 20, d is given as 10 minus x. So 10x equal to 200 minus 20x, 30x equal to 200, x equal to 200 by 30 or 20 by 3, the same answer, you can get that way also. So these three are the three very simple questions given in system of particles, rotatory motion and center of mass in NEET 2022. Thank you for watching.